So in our circuit, we have two 1.5 volt batteries, which means we're going to have a total of 3 volts running through our circuit. And other components are, for now we're going to use one single light bulb to show this demonstration and one capacitor. So since the capacitor is hooked up to the battery, it should have 3 volts. And as you can see, it does by the reading on the voltmeter. So now, in order to light the light bulb, we're going to disconnect the capacitor from the battery because it's had plenty of time to charge, and reconnect to the light bulb. And the light bulb slowly dims because the capacitor is running out of charge. So now we're going to repeat the first experiment, only now we want to see what happens when we use the same voltage of 3 volts, the same single capacitor, but now with 2 light bulbs. So, like before, I'm going to disconnect the capacitor from the battery. And it looks like they burned out much faster than the previous experiment. So now we're going to be redoing this experiment using, again, the 3 volts, 1 capacitor, but now what's different is we're going to be testing it over 3 light bulbs. And our hypothesis is that now that we're adding an extra light bulb, all 3 will burn out faster since we're, again, only using the 1 capacitor. And like previously, the voltmeter says we have about 3 volts going to the battery. So now I'm going to disconnect the capacitor from the battery since it's charged. And I'll just connect them on one side first. Try to do 2 quickly at once and then get the other one as fast as possible.
Okay, so here we are modeling in series capacitors. So each of these capacitors could be charged to 3 volts individually, and so when we have them charged up, the electrons will go from here around this black wire to the first capacitor, and then it'll charge up across the capacitor, and then this capacitor is connected to the second capacitor, which then the electrons will build up and go across this capacitor to light up the light bulb there. So for this demo, we're modeling capacitors in parallel, and so again, both of these capacitors can be charged to 3 volts individually. And so if it's in parallel, the electrons start here, and they go along this black wire, and when they get to this point, they have 2 choices, so 2 different branches that they could take. They could either build up across the capacitor, or they could take this wire and go to the second capacitor. Both electrons, however, will end up in the same place, as if they build up across here, this wire connects it to the end of the second capacitor, and if they took the second route and started building up across this capacitor, they would also end up here to then be connected to the light bulb.
Okay, so now we have 2 capacitors and again 2 1.5 volt batteries, so we want to charge each capacitor to be 3 volts, and we can do this by putting them in series in the way that we just previously explained. Okay, so I'm now going to take this ground and put it over here. and I'm going to take this end of the wire and light up the bulb. And it took about the same time to finish or to stop the charge lighting the bulb as it did in our first trial when we had just a single capacitor. Now that the capacitors are in parallel, the total voltage going to the light bulb is 6 volts. This makes sense since the light bulb stays lit longer as seen in the video.